Hello, welcome everybody. Here is your quiz you guys took the other day. I'm going to go through 3 problems. This was number 1 on the quiz. This is the minimize the amount of paper used. I'm not going to be able to underline this really well because my stylus is too thick here. But for this problem, it's minimize. So this problem is going to be an optimization problem. I'm just going to run through the general ideas so that you guys can get an idea. This is about a poster, and then in the middle of the poster, because it's got a border on it, you have this amount of text. So you're designing a rectangular poster to contain 256 square inches of printing. Now the printing is right here. 3-inch margin at the top and a 2-inch margin on each side. So I'm going to change colors here, and this is going to be tough. So right here you got 2s. And then down here and at the top, those are 3s. Okay. What overall dimensions will minimize the amount of paper used? So if you want to minimize paper, paper is an area problem. I know some of you might have tried to do perimeter on this, but I want to minimize the area. So the area is the whole paper. So what I'm going to do is I'm going to use a variable here, and I'm going to call this side length L, and this side right here width W. It doesn't matter which side's L, which side's W, but then the area of my entire paper is going to be the L side, that little green side on the bottom there, and then you got to add the 2 and 2 to get 4. You multiply that because it's length of the whole thing times width of the whole thing, and the width is going to be that W plus the top 3 and the bottom 3 is plus 6. Now, it would be wonderful if I could just go from here, FOIL it all out, and say take the derivative set equal to 0 and solve. But the problem with optimization is you have to have the same letter. So we didn't use the 256 yet, so I need to use that 256. The area of the inside is equal to L times W. That's why I defined the L and the W to be the inside, because I could look ahead and tell that if I decided this to be the L and this to be the W, it wouldn't matter, and then I'd have to use subtraction. But it's a little easier to do it this way. So if the area is 256 equals L times W, then all I did was divide by L so that I only had W's. And then I'm going to replace this W, so I only have L's, sorry, with 256 over L plus 6 times L plus 4. And then what I ended up doing is I ended up doing a little foiling with these two things because I don't want to use product rule. That looks like a pain in the butt. So I'm just going to FOIL it all out, and I hope I did this all right. I end up with 6L plus 280 6L plus 280, then plus 1024 L to the negative 1. Or you could have said over L also. That's your A. Then you go with A prime. A prime equals 6 minus 1024 L to the negative 2. And then you can plug this in your calculator, and you can find the zeros. You end up with the L equals 13.0639. And then that kind of leads you down the path of thinking that this problem might be A. However, the way I defined it, this is my length right here. Let me put that in red so you can kind of see it right there. And I really need to go back and add to that the 2 on this side and the 2 on this side. So it's 13 plus 4. So it's really a whole paper of 17. That's the tricky part at the end. Now you could kind of stop here because the only one that has a dimension of 17 is C. If you wanted to keep going, you can. You could plug in your L here, and then you can get your W. But that's how you do number 1. So the next one I'm going to move to is this one, which once you see it, you'll go, really? It was that easy? And yes, it was. This was number 6. So this problem here, you have V equals, this is a right circular cone, 1/3 pi r squared h. 2 letters. The volume of right circular cone is this, r in the radius and the height. Now, you need to find dv, so that's obviously you just need to find the derivative. However, we normally don't like two letters, but in this problem, two letters are okay. Why? Because you have both rates right there. So all I'm going to do is do the product rule, this being the first, this being the second, and you do the first 1/3 pi r squared times the derivative of the second, dh dt, plus the second, h, times the derivative of the first, bring that 2 in front, it becomes 2/3 pi, lower the power to 1, dr dt. Now this is a 1, doesn't look like a prime, I hope that you don't think that, that's a 1. And then you just plug in all your numbers. So I'll just plug them in and I'll let you guys, worry about the solving. R is 4, so then this would be 4 squared. You have a pi, you have a 1/3. dh dt, do I know that? Yep, that's a -3. Plus h, do I know h? H is 5. Then you got the number 2/3, then you get a pi, then you get an r. R is 4, then you got a dr dt. dr dt is 6. And then you just multiply all this out, use your calculator, whatever you get, that's your answer. It is that simple. It does end up to be 64 pi. If you leave the pi's in there, it ends up to be 64 pi. And checking my answer, that is D, that is correct. And then when you last one, this is kind of tricky, but I tried to help you set it up, so I'll reset it up. You got this lamppost over here. You got this person walking right here. That's my person. And then you got two triangles, this big red one. And then you got this other triangle here, this brown one. Okay. The trick to this is as you draw this picture, this right there is 5.5. And the lamp post is 22. These are not changing items, so you could plug those into your function right away. What is changing? This and this, because they're walking toward the lamp post, toward the street light. Yeah. So this guy's walking in this direction, so both this is shrinking and this is getting bigger. So in class, I kind of helped you by setting it up by calling this X and this S. So when I set this up, I'm going to go with I know that there's another number in here, and that's 15. I'll put that in red right here. But that 15 is changing. I cannot put that in until after the derivative. Now what formula? Triangle. Triangles have a couple. There is no angle, so SOHCAHTOA is irrelevant. There is a length you're talking about here, so Pythagorean theorem might be okay, but that would be really challenging for a problem like this. Because of the two triangles, it's just like what we did in class the last couple days with the similar triangles. So I'm going to set it up in a fraction, similar triangles. And I'm going to say that this bottom, I'll use a laser pointer, which happens to be a lightsaber, this bottom S compared to this side, 5.5, that's the little triangle in brown, is equal to the big triangle. Now the big triangle's bottom, corresponding bottom, is all of this. S and X change. 22 doesn't change, so I can put that in right away. So I'm going to change to brown for the brown triangle, and I'm going to go S over 5.5 equals, then I'm going to do the same corresponding side, so it's the bottom, X plus S equals, or over 22, the right side. So the right sides are on the bottoms are on the top. And then to solve this problem, I'm going to do a little cross multiplication. I'm going to get 22S equals 5.5 times X plus S. And then I'll distribute that in, so I get 22S equals 5.5X plus 5.5S. I'm going to bring this guy over, so I end up, well, actually, you know what? What did I do? Yeah, I can bring it over. So I get 16.5S equals 5.5X. From here, you can take the derivative, and you can plug in the things you know. because this is going to be your 0.5. I did do one more step here, and I did divide 16.5. You don't have to at this point. There's lots of ways to solve it. So now I'm coming up here, I'll change colors, and I go S equals, and the beautiful thing about this, 5.5 over 16.5, that's 1/3. 1/3 x. Take the derivative, ds dt, equals the derivative, 1/3 dx dt. Plug in all your numbers. This is -6. 1/3 of -6 is -2. And then that's your ds dt, which I believe was a. Yep, that's how you do it. I hope this helps go through these. These were tricky problems. I realize that. I was hoping that you got a little help from your friends, and possibly you just needed more time. I'm not sure. Thanks for listening. Don't forget, if you'd like extra credit by watching this video, just post a comment with your name, Jim watched video or whatever. Thanks for listening. Have a good weekend.